A very good morning, children. In this video, we are going to extend our concept regarding the potence of hydrogen that we had learned in our grade 10 standard. This is the very useful topic for the objective examinations point of view. So let us see and study in detail what is about the pH. In 10th standard it is just introduced to you just like pH. It is the potence of hydrogen. Used to be given like a tablet form. It is having values from 0 to 14. Is it not? 0 to 6.9 we used to say it is an acidic substance when the pH is 0 to 6.9. If the pH is 7, we used to say it is exactly neutral like distilled water. And when the pH is 7.1 to 14, we used to say it is a basic substance. So based on the value ranging of the pH 0 to 14, we used to say whether it is an acidic substance, neutral substance or basic substance. But now we are giving a new definition. In the last video, we learned about logarithm and anti-logarithm. Here, what we are defining about pH is the negative log base to the concentration of H plus ion. What is pH, children? pH is equal to negative log to the base 10 into concentration of the H plus ion. This is the definition of the pH. But we are bringing them in the form of an derivation form, equation form. Or we can write this pH which is equal to negative log base 10 to the concentration of H plus ion. Where do we get this H plus ion? Generally acids will give the H plus ion. Now our pH means it is going to represent what is the concentration of the acidic substance present in the solution. Sometimes we will go for the potence of hydroxide ions. At the time we will use negative logarithm to the base 10 to the concentration of OH minus ion. Later we will see about that. But now see this pH what is equal to negative logarithm to the base 10 to the concentration of H plus ions, we can write in three different forms. One is this one. What is this one? pH is equal to negative logarithm to the base 10, or we can write pH is equal to log base 10 to the 1 by concentration of H plus ion, because we are going to remove the negative sign here. pH is equal to log base 10 into 1 by concentration of the H plus ions. Concentration of H plus ions also can be mentioned as the concentration of hydronium ion, means H3O plus ions. So we are bringing pH is equal to log base 10 into 1 upon concentration of the hydronium ion. So in these three methods we can express the concentration of the solution. One example was brought here. For example, calculate the pH of 0.001 molarity of HCl. Generally, our potence of the hydrogen or the pH is expressed in the molarity. That is what we brought in the first definition. What is pH scale? If a question is given, we can say it is a negative logarithm scale used to express hydronium ion concentration in molarity. How are we expressing this concentration? We are expressing the concentration in the molarity. So generally we got this one 0 to 6.9 we said is an acidic substance, 7 is neutral, 7.1 to 14 is the basic substance. That's what the pH scale that we used to range from 10th standard. But this is what actual definition. pH of the solution they ask you, then you must say it is the negative logarithm to base 10. Here negative logarithm to base 10 of the molar concentration of the hydronium ion. Means H plus ion, we can hydrogen ion we can take, or hydronium ion also we can take. So let's continue with our question. So HCl on dissociation it will give how many H plus ions, children? Only one H plus ion. So we want this H plus ion 0.01 molarity. We want to express that pH in scale. So how do you express pH is equal to, what is the formula? pH is equal to negative logarithm to the base 10 to the concentration of the H plus ion. What is the concentration of H plus ion? 0.001 molarity. Or I would like to express this in scientific notation. How? Scientific notation. Then I would like to take 1, 2 and 3. I can express this one as 1 into 10 to the power of minus 3 molarity. Or we can simply say 10 to the power of minus 3 molarity. So I am expressing this pH is equal to minus log base 10 to the concentration of H plus ion. So minus log base 10 to the concentration of 10 to the power of minus 3. Last time do you remember children? Log B to the power of A. How had we taken? A into log B. A into log B. Now what is there? 10 to the power of minus 3 is there. So shall I write minus 3? This is regarding the log value. So log 10 to the power of minus 3, how we will write? Minus 3 into log base 10 to the power of 10. Generally log base 10 we can also write it as the log 10. What is the value of that? 1. So minus 3 into 1 again will come as the minus 3. Is it not? So minus log base 10 into concentration of H plus ion, that is the power of minus 3 is written as minus log b to the power of A written as A into log B, or log 10 to the power of minus 3 is equal to minus 3 into log base 10 whose value is 1. So minus 3 into minus, already here this minus is coming, minus 3 into log 10. Log 10 is 1. Minus into minus plus we know. So what is the pH value we got? We got the pH value as 3. In this method we will apply our equations. So let's continue what is meant by the potence of hydroxide ions. Means when a substance is dissociating in the basic medium, basic solution, what is the pOH of the solution? In the previous session we had learned pH is equal to negative logarithm to the base 10 of concentration of the H plus ions. But when you are going to calculate the pOH of the solution, you will say it is equal to negative log base 10 to the concentration of OH minus ions, hydroxide ions. Right. For that we got the definition here. Negative logarithm to the base 10 of the molar concentration of hydroxide ions. Instead of writing these definitions, we are writing what the pOH of the solution is equal to negative logarithm to the base 10 to the concentration of the OH minus ions. Or we can express pOH is equal to negative logarithm to the base 10 of the concentration. 1 upon, here if you remove the negative sign, you must write 1 upon concentration of the OH minus ions. Now let us see one question, then we can understand how we are applying. Don't forget one key point student, the pH and the pOH together when we combine, they will be equal to 40. That is the main key point. What is the key point? The pH and the pOH when you combine or when you add to each other, that value will be must be equal to 14. Then only we can solve any of the problems of this kind. What is the problem given here? Let us see here. Calculate the pH of 0.02 molarity barium hydroxide solution. Then only this barium belongs to second group. We know alkaline earth metals were in their hydroxides when dissolved in water will form the bases. So the barium hydroxide on dissociation will generally give barium ion and two of the hydroxide ions. This one will be in the form of equation. Barium hydroxide on dissolved in water will give barium ions, two charged Ba2 plus ion plus 2 of the hydroxide ions. But what is the concentration of the solution given? Molarity 0.02 molarity. But how many of them are given when they are dissolved in water? 2 of them are produced. So we say 2 into 0.02 molarity. Now what is the concentration of OH minus ion in this solution? OH minus ion concentration is equal to 2 into 0.02. We can write this one as 0.04 molarity. or when you are expressing in the scientific notation, you know, you need to bring this one in the forward. How many places had I bring forward? 2 places. So 4 into, when we are going to right side, 10 to the power of minus 2, it will come 4 into 10 to the power of minus 2 molarity is the concentration of the OH minus ions. But we are applying that into this equation, which one? Potential of hydroxide ions. First, if you know this one, then you can automatically calculate the pH. See, actually our topic is P of OH. But what is the question given? It is asked to be obtained pH. But what we know, pH plus pOH is equal to 40. So if you are able to solve what is the pOH, then automatically you will get the pH. So first of all, we are going for the pOH is equal to minus log base 10 to the concentration of the OH minus ions. What is the concentration of OH minus ions we got? We got it is equal to 4 into 10 to the power of minus 2. So pOH is equal to log base 10 minus log base 10 to 4 into 10 to the power of minus 2. This is in which format? Log A into B. Now we can express this one as the log A plus log B. Means log base 10 into 4 plus log base 10 4 plus log base 10 to the power of minus 2. So log A plus log B will form. Now we already know the value of log 4. Generally we had it as 0.6, right? But this is in the format of log 10. These are all log base 10. Log base 10 to the power of 10 minus 2. How shall we write? We will write this one as the expressing log B to the power of A, or A into log B we can write. So I would like to write this one as minus 2 into log base 10 to the power of 10. Log base 10 to 10. Or we can, if you forget this, can you simply say log 10. These are all log base 10 values only. What is the value of log 10? Log 10 value is 1. So when you are bringing plus into minus, it is giving you minus. So minus log base 10 to the power of 4. What is the value of this one? 0.6021 is the actual value. Last time I had given the rough value. So minus of 0.6021 plus minus to minus plus 2, because this value became 1. So you are subtracting minus n plus is there. So you are subtracting this value from the 2. Then you will get 1.3979. So what is this one? This is the concentration of the pOH ions. But what we know, pH plus pOH is equal to 40. So pH is equal to 1 plus 3, 1.397 is equal to 40. Now pH is equal to 14 minus 1.397. You are getting the pH. So applying in the objective examinations, if they ask calculate the pH, you must apply these two R equal to 14. Then you can solve the numericals. Right now, we are continuing our concept. Let us see here, children, about the determination of this pH. How do we determine the potential of hydrogen? The potential of hydrogen can be determined in many ways, but only 3 ways are given to us. One is using the pH paper. In the pH paper, there will be the values, or there will be colors. Most probably there will be colors to observe. With change in color, and you can observe what will be the change in the pH. Or there will be indicators. pH indicating buffer papers, like you can see this pH paper, or there is a pH universal indicator. But these are all rough values. We don't know how much is the pH. But to exactly identify, just like our pen, there will be pH reading scale meters. pH meters we can call. By those pH meters, we can calculate the pH even if it is very small, like 0.001 molarity. So using pH papers or pH universal indicators or pH meters, we can calculate the pH of the solution. But presently we are studying about a new concept regarding whenever we see about strong acids, the dissociation is more. But whenever we study about weak acids, then dissociation is less. So now we are beginning the topic about regarding the dissociation of the weak acid and the weak base. What are they going to be called? Let us take one on the weak acid, acetic acid. What is the formula of acetic acid? CH3COOH. On On dissociation of this acetic acid, what do they will give? CH3COO minus and the OH minus L. But H plus L, sorry. But it does not undergo complete dissociation. Yes or no? Weak acid means what? It does not undergo complete dissociation. So now we are bringing one constant. The constant that is observed at this equilibrium is called as the acid dissociation constant. And the constant that is observed in dissociation of a weak acid, it is represented as the Ka. It is, for example, the acetic acid we have taken. It is the ratio of product of concentration of the products. Product means what? Multiplication of concentration of the products upon concentration of the reactants. What is the ionic? What we can say? The acid dissociation constant, the weak acid dissociation constant, that will be given as the Ka. It is equal to the ratio of product of concentration of products upon product of concentration of the reactants. Here we have the acetic acid CH3COO minus, H plus are the products, and reactant is the CH3COOH. Now the similar definition once again I am reading for this Ka or acid dissociation constant. The ratio of product of molar concentrations of dissociated ions to the molar concentrations of the undissociated acid molecules at a given temperature. So at a given temperature we are observing. Similarly, we will apply the same for the basic dissociation constant for weak bases. We know ammonia is one of the weak base. So ammonium hydroxide, which is a weak base, on dissociation will give NH plus and an OH minus. So the same we will apply, but in numerical we are changing Kb. It is equal to concentration of the product of the products. What are the products here? NH4 plus to the concentration of the OH minus ion upon NH4OH. NH4OH. Last time we had seen one value now. What is the value we had seen? pH plus POH is equal to 40. Is it not, children? But now we are bringing a relationship between Ka and the Kb. What is Ka? Acid dissociation constant. Which acid dissociation constant? Weak acid dissociation constant. What is Kb? Base dissociation constant. Which base dissociation constant? Weak base dissociation constant. The relationship between Ka and the Kb is given as the Ka into Kb is equal to 10 power minus 14. But in the last session as we had learned, Kw, ionic product of water, is equal to 10 power minus 14. So the product of Ka into Kb we can also write that is equal to Kw, ionic product of the water. Now what is the importance of this Ka? What is Ka? The acid dissociation constant. Means it is used to determine the strength of the acid. So when the Ka value is more, we can say the acid is more strength. It is having more pH. That's what we are bringing. At a given temperature, Ka determines the strength of the acid. So rather the Ka value, stronger the acid will be. Rather the Ka value, stronger the acid will be. Now if we say the Kb determines the strength of the base. Similarly we can say now, larger the Kb value, we can say the basic strength will be more. So these are the small concepts regarding Ka and Kb.